Okay, so next we are going to learn about how to deal with the work term. So we have the free body diagram. X really shows the direction of the displacement. So that's what you need. You need to see the displacement direction. And relative angles between the forces and the displacement. So the work term definition is F dotted with D, right? And in magnitude, it is FD cosine theta. Okay, so because it's a dot product. So that keeping that in mind, we are going to think about that work term first. So what is that work term? WA has three parts because there are three forces, so I'm just going to write them. There is WF, there is WW, that's the work done by the weight force, and the work done by the normal force. Even if you know any of those to be zero, just write them down and then think about if there is any zero terms. So again, because of the dot product, cosine function will determine if you have zero work term, because we know that there are forces and there's displacement, right? F and D cannot be zero. If it is zero, it's just going to be because of the cosine theta function. And we know that if it is 90 degrees, then, or 270, then we will get zero cosine, zero as the result of the cosine function. So we need to just check those angles. So one thing I clearly can see is the normal force and the displacement, they are perpendicular to each other, right? So we can get rid of the work done by the normal force. And we can simply say it's because n is perpendicular to the displacement. Okay, so the theta in cosine function here is simply 90 degrees. And cosine 90 becomes 0. Okay, so, and if you think about that, F and D, they're not 90 degrees, so there's going to be some non-zero work done. Do you think it is a positive work or a negative work? Since the angle is larger than 90 degrees between F and D, okay, and when I'm talking about the angle, just want to kind of show you, I'm talking about this angle here. And we already know that this portion was 20 degrees and that line is extended line from D, so the rest is gonna be 180 minus that angle, and that becomes here 160 degrees, right? So that's the angle we will be using for work done work done by F. What about the weight force? So weight force, the angle between the weight force and the displacement is not 90 degrees. So it is actually doing work. But remember, we need to make a choice. Do we want to keep the change in energy, potential energy term? Or do we want to ignore that and then keep the work done by the weight form? You cannot keep both of them. Okay, that means double counting. And you will get a wrong answer. So, because the change in potential is the gravitational potential, it is related to the gravitational force, the weight force, right? So you have two terms, and there's the weight force, the work done by the weight force on the right side as the work term, or delta U, the change in gravitational potential on the left side. Since I've already kept delta U and I didn't set it to 0, I need to get rid of the work done by the weight force here, okay? Because that's already accounted as delta U. That doesn't mean work done by the weight force is 0. It is non-zero, okay? You can even calculate it if they're asking you to figure it out. What is the work done by the weight force? It is definitely not 0. The reason I'm saying this is 0 because I've already counted it as delta U in the energy conservation, and I cannot double count it again, okay, because we are doing this work done, total work done for the energy conservation, right? And the next step will be putting all these together then. So I have delta K, writing my energy equation again, delta K plus delta U, again remember I kept that, that's equal to work done term becomes only the work done by the applied force. So that's what we have. So this is what we got, and the next step is going to be kind of simplify this. What is delta K? It is final minus initial. What is delta U? Again, final minus initial, but in the form of potential energy. And what is WF? Using the work definition, FD cosine theta, so it's F times D times cosine of 160, right, as we figured it out. Okay, so let's now think about the energy terms again. Do we have any zero energy terms? Okay, so for this one we gotta go back and then kind of remind ourselves what the problem was about. It's said that it starts from rest. That means initial velocity is zero. That makes the initial kinetic zero. And the block is gonna go all the way down the ramp. And I want you to kind of see what I've done with the y direction and why do I choose it there. That is that is what you need to do for the potential energy. Okay, so when you write the potential energy, you should always you must take the positive y component upward. That y direction has nothing to do with the free body diagram or that x direction that I showed. Okay, this is for simply for delta U, but nothing else. Okay, so and what I'm saying is ground is y0. That means at the end the final potential energy will be 0. So if we go back and kind of carry those in, show the cancellations, we said that there's no initial kinetic energy because remember initial velocity is 0. We're also saying that final potential is 0 because we set up final y to be 0. Okay, then we have a little bit more simplified equation. What is K? K is 1/2 mv final square. And be careful with the signs. Minus ui potential energy, it's mg y initial, right? So I'm writing the energy terms in their form, and that's equal to f d cosine 160. Okay, so I cannot cancel off m's or anything like that, so we're just gonna plug the numbers in now. One thing I like to do though, I like to get rid of that 1/2 so that I don't make mistakes. So what I'm gonna do is I'm gonna multiply each term by 2, and here 2, and here there. Every term is multiplied by 2 so that I can cancel out the 2's here. And let's just see what we have. In the problem, I'm going to read the problem again. It says 50 pounds block. So the weight force is given, right? But we don't know the mass of it. So we need to figure that out. And I'm gonna show that in another video because I don't want to overload the videos.